For this module on the revision package, we'll be handling vectors. And the question that we've chosen to use is the 2017 A-Level Paper 1, question number 10. We have modified this question such that it is relevant to your CT1. This is the question, the modified question from your CT1. Almost everything is intact, except we add certain bits to help you a bit, since you have not gone through vectors 6 yet. So try reading this question first, pause the video, and if you're comfortable doing this on your own, by all means do it on your own. But if you cannot handle this question, after reading it for about 2 minutes, I suggest you continue with the video. So before I go into handling that question, let's go through some techniques or strategies involved when you are trying to solve contextual questions. The technique that I'm going to introduce to you is the CSI technique. You need to comprehend the question, strategize your move, and then implement your techniques. So what do I mean by comprehend? To comprehend means that you need to understand the story or the scenario given to you. And thereafter, you need to highlight key information pertaining to the question. And next, highlight any initial conditions. Once you've gone through that, your job next is to strategize. Strategize means identify the topic relevance. And for this, we have actually identified the topic as vectors. But then you need to identify the subsections in the topic that you have identified. And then pull out the relevant formula or the templates that you have learned before in these subsections. Thereafter, devise a strategy based on what you have comprehended and identified. And in the final stage, you actually have to implement, carry out whatever you have planned out and start working on your strategy. But in the process of working on your strategy, there may be a need for iterations. Iterations means that you need to reread the question, you need to re-strategize and come up with a new plan if necessary. So coming back to this question, let's run through your CSI technique. So the first thing you need to do is, of course, read and comprehend. Read the story given. This is a vectors question, but it's embedded in the form of electrical cables. So your objective is to find the value of A for which C and the new cable will meet. So after reading this question, you need to sort of understand that the subsection in your vectors that we're trying to look for here is the intersection of two lines. And before you can find the intersection, you need to plan your strategy. I need to find the equation first before I can find the intersection. And after you find the equation, I need to equate the two lines together. And of course, before you can actually find the equations, you must pull out the necessary info. The first equation is existing cable C. Do you have the equation of the line? The equation starts from, the cable C starts from the main switching site, which is 0, 0, and in this direction. New cable passes through P and Q. So these are the critical information that you need to highlight pertaining to this question. Next step, implement. Find the vector equation of the two lines. So you have identified your P and Q. A sketch will actually help you a bit. You identify your P and Q. This is the direction of the new cable. It starts from either point P or point Q. So one start point, one direction. Cable C starts from the origin, which is the main switching point, and it's in the direction of 3, 1, minus 2. So what you have here is you have actually generated the equation of your two cables already. What is your next job? Your next job is to find when the cable meet. So you equate the two equations together, the two vector equations together, and you actually will generate 3 separate simultaneous equations. Take note, there are 3 unknowns in these 3 equations. Solving equation 1 and 2 will allow you to solve for lambda and mu. With the lambda and mu that you found in 1 and 2, you can pump back into equation 3 to get your value of A. And that's how you handle the first part of the question. Moving on, okay, the question now changes. Now they tell you, oh, take the value of a to be minus 3. Okay, and then they tell you there's a new point OR given in the form of 3, 1 minus 2, where R is a point on the cable C. Okay, so this is actually your comprehension process. Again, you need to comprehend the story now. So now the story says that the engineer wishes to reduce the length of the cable such that PRQ should be 90 degree. Your job is to show that this is not possible. So catch some hint from the question. You see a 90 degree. So angle PRQ should be at 90 degree. So strategy wise is that it got to do with dot product. Dot product of who? Angle PRQ will then mean PR dot RQ must be equals to 0. So this is your strategize part. Once you have strategized, implement. Solve by finding QR and PR. So using your vectors addition, you can actually find vector QR and vector PR. And then because they are at 90 degree, dot product must be equals to 0. So dot product of your two items, you actually end up with an equation that involves mu. So here is when students actually get thrown off. What are you trying to do? Your job is to show that it is impossible. So go back to the question and re-strategize again. Okay, your job is to show that it is impossible. Impossible for what? Impossible for PRQ to be at 90 degree. But what have you done previously? You have shown that you have tried. You have considered QR.PR is equal to 0, and you end up with an equation like this. Okay, a power 2 equation that involves mu. But then, how to show that it is impossible? Okay, how do I show that it is impossible? So you need to think again. Activate again other strategies, maybe from a secondary school or whatsoever. And then you need to think, I cannot solve equation. Equation cannot be solved will then mean there are no real roots. When there are no real roots, how can that happen? Discriminant must be smaller than 0. So you need to activate your secondary school skills here. So now you run what you have strategized and run a discriminant test, and then show that the discriminant actually is smaller than is negative. Hence, you can conclude that angle PRQ cannot be equals to 0.